Welcome back, everybody. So we are finally back into like a normal routine. Chapter 4, we're going to get back into, notes, homework, warm-up notes, homework, warm-up notes, homework, and so on, until for the foreseeable future. Now, just to let you guys know where we're headed, because it's kind of getting down to it a little bit. We have this week. Next week is Thanksgiving week, right? Next week, the 25th, that's Thanksgiving. So we have this week and then 3 days. So we'll hopefully get sections 4.1 to 4.3 and then a quiz in by next Tuesday. Okay, maybe next Wednesday, we'll see. Then when we get back from Thanksgiving break, we don't have school the 29th, but then the 30th through the 3rd, and then the 6th through the 10th, we have school. And then that 13th through the 17th, that is exam week. That is exam week, which means that the 15th, 16th, and 17th are our exams. It all depends on the exam schedule. They've released the exam schedule, but we haven't really talked about it that much. I'm sure you'll hear it in mentoring classes and whatnot. But basically, you have hour-and-a-half chunks of time where you go and you take your exam, and you come into that class and take your exam, and then you go. I always have people say, "Oh, when's the Christmas party?" This is high school. There is no Christmas party. There is no assembly. There's no concert. It's just like, here, have an exam. Feliz Navidad. But the 15th, 16th, and 17th, that's our exam. Those are our exam days. Those are our exam days, the 15th, 16th, and 17th. And then you'll come back and we'll start the next semester. Sound good? I've been asked before, what's on the exam? Like, is that just this 9 weeks? That's the first and second 9 weeks. You will take the first semester exam on those days. Then in the spring, in May, when it's like the end of school, last day of school, you will take the second semester exam. Okay, which is the third and fourth 9 weeks. That is not a full year exam at the end of the year. That is just the third and fourth 9 weeks. You have to. It's like an open campus time where, like, if you have an exam during that period, you come and take it. You have to be here for the full hour-and-a-half chunk of time, or 2 hours, or whatever it may be. You have to be here for that full amount of time. It's not like you can turn it in and walk out. But if you have like a study hall during a period, or if you have like a class where you don't take an exam in for that period, then you do not have to be here during that exam time. So say like, oh, I've got a study hall 6th period. During the 6th period exam time, you just don't have to be here. Okay, so you can like sleep in if it's in the morning or whatever it may be. You don't have to be here during that exam time. So you can go in the student center, you can go in the SOC. A lot of juniors and seniors leave, go home for a little bit and then come back. So it's like an open campus during that exam time. Does that make sense? Does that answer your question?
Yeah.
Okay. I'm sure, I know it's new to you guys, so it'll take a lot of explaining, but I'm sure we'll get there. If you don't show up to school, then you get a 0 on your exam, which is not advisable. Yes.
But what if I was like on the bed, like I can't even move?
Now, there are extenuating circumstances. If you have like a doctor's note, like there's something wrong with you, then I have, like, because there was, actually this happened a lot last year because a lot of students got quarantined for exams last year. There was a big chunk of students that got quarantined for exams. And then I had to, we either gave those exams digitally or we gave it to them when they got back.
So those students like all aced their tests and they looked up answers up on their phone?
No, it was like they had to do it on a Google Meet. And I recorded the Google Meet the whole time. So the camera had to be pointed at them the whole time. So at least there was a little bit of test security. It's crazy. Like I took a couple online classes like 2 years ago to be able to teach CCP Calc, and it was through Kent State. And now they have this program that, like, if you move at all during your test, or if your camera moves at all, it flags it and it records you the entire time. So if you move during your test, except for when to start or end the test, it will shut off. and it'll make you like verify that you're back in it again. And like at the start of my test, I had to take my camera and swivel it all the way around my room to prove that no one was there with me. It was like the craziest thing. It was like very, very, very insecure. It was nuts. It notified whoever was like the proctor, like if I went to a different tab in the browser, like or if I did anything else on my computer, it notified the proctor. It was really weird. All right. Anyways, so yeah, a lot of things just to say don't cheat. All right. All right. Section 4.1. So now we're in this mode of writing equations. Okay. We're in a new chapter now. Chapter 3 was all about graphing. Now we're not leaving graphing behind. We're just kind of like shifting our focus away from graphing, taking our focus away from graphing to writing the equations. Now it's not about like, okay, here's the equation, see what it looks like on the graph. It's here is a bunch of different things. Maybe it's a graph, maybe it's points, maybe it's other information. Write the equation that models that line. Okay? So read the title here, writing equations in slope-intercept form. Can somebody remind me, what is slope-intercept form? Y equals mx plus b, which m is the slope and the b is the y-intercept. Man, we've done that a lot, right? If we don't know that by now, there's something wrong. M is the slope, b is the y-intercept, right? What we're going to be focused on here is writing our equations in this form. Okay, literally, if I want you to write the equation in slope-intercept form, read it slope-intercept. I need the slope and the y-intercept. I need to be able to identify the m and the b. I'm going to do this every single problem today. I'm going to say, what is my m? What is my b? Well, the first couple examples are super easy. Why? They give us the m and the b. I mean, it could not get more simple than this. The slope is -3. The y-intercept is 1/2. Oh my gosh. They give us the exact piece of information I need. So my equation is y is equal to -3x plus 1/2. Just as simple as that. Literally, that's it. I give you the slope, I give you the y-intercept, you write the equation, y equals mx plus b. Done. That's all I'm asking you to do right now. Let's do another one. Let's think about a special case. I've got my slope is 0 and my y-intercept is -2. So I'm going to go here. I'm going to say, okay, m is 0, b is -2. Let me ask you guys a question. What type of line has a slope of 0? A horizontal line. A horizontal line. What type of, a horizontal line has what type of equation? That's a slope. Y equals. That's what I'm getting at there. Y equals a number. Let me show you how I get that from here. If it's y is equal to mx plus b and my slope is 0, I have this, right? Some people might try to leave that on an answer blank. I would advise against that because what is 0 times x? 0. And isn't that just going to go away? So it ends up just being y is equal to -2. Oh, there's my y equals equation. Okay, y is equal to 0x minus 2. There's my y equals a number equation. Okay, well, what if I switch it? What if I say my b value is 0? What does that look like now? Well, here's my slope is -2. My b value is 0. What if I change it up? Well, in this case, I'm just going to plug it right in. Y equals mx plus b. Now, in this case, do I really need to write the plus 0? No. So I'm going to knock off that plus 0 on the end and say y is equal to -2x. And there's my answer. We'll learn a little bit later on in the year that this is actually what's called a direct variation, something that is proportional throughout the graph. Okay? All this is saying, all the 0 is saying is that it runs through 0, 0. So like there. That's the graph of that line. any equation with the y-intercept of 0 just says it runs through the origin. It's not horizontal, it's not vertical, it just runs through the origin, that's it. And if it runs through the origin, it's a special name called a direct variation. The slope is proportional all the way throughout. Okay, y is equal to 1/4. The slope is equal to 1/4. The b is -5. Somebody tell me what my equation should be.
Y equals 1 to 4x minus 5.
Good. Please again, don't write plus a -5. Don't do that. Just write -5. Now, why did I have us do so many of those? That should have been super easy, right? Why even 4? I could have left it at one example. Here's why. I wanted to show you how easy it is to write the equation when given the slope and the intercept. Okay? Because if you can get to this point, writing your equation is really simple. If you can get to that point. The rest of today is trying to get to this point. Trying to get to a point where we can find the slope and the y-intercept. Then it's really easy to write the equation. So from here on out, I'm going to switch up what I'm giving you. Okay, what if I give you a graph? Again, if I ask you to write it in slope-intercept form, I should be able to identify what the slope and the y-intercept are. Let's start with the easy piece of this. What is the y-intercept of this graph? Henry? -3. Good. -3. Where do we see the y-intercept? Where it crosses the y-axis. Now, am I explicitly given the slope? No. But am I given a way to find it? Yes. And that's what we're going to be doing from here on out. Finding the slope so we can write the equation. Oh man, when we're given a graph, I can find the slope. That was on your test. Given a graph, find the slope. Count our boxes, folks. Rise. 1, 2, 3, 4, 5, 6. Run. 1, 2, 3, 4. Okay. So my slope should be rise 6, run 4. Is this a positive or negatively sloping line? Positive. So I can leave it positive. Now, can you leave your slope as 6/4? No, that needs to be reduced.
1 1/2.
Okay, let's write it as an improper fraction rather than a mixed number. 3/2. Somebody last period said 3/2. Not calling out anybody, Colin. But he said 3/2. Sure. Yes. So y equals, let's put in our equation now. 3/2 x minus 3. I guess that would, is that a proper way to say 3/2?
No, it's not. It's just
3/2. There we go. 3 seconds, I guess we should say. Questions about that one? Okay, let's do that one more time. Still the same type of thing, just doing it again. Let's, again, first identify my y-intercept. What's my y-intercept of this line? 2. 2. And now we find my slope. I go down 1, 2, 3. I go over 1, 2, 3, 4. Okay. This is do you all see the negative sloping line? Going down and to the right, it makes the crossbar of the end. So I know that this is a negatively sloping line, and I can see it right in my numbers here. -3/4. Rise 3, run 4, and it's a negative sloping line. Down 3, right 4. All right, I take those two pieces, and I say y is equal to -3/4 x plus 2, and there's my answer. questions about that? Okay, pretty simple still, right? So now, let's just kind of keep adding layers a little bit. Write the equation of the line again in slope-intercept form. Again, y equals mx plus b form. So if it's in mx plus b form, I should find the m and the b. Now, am I given, see, we started out with my graph identifying the y-intercept. Am I given the y-intercept here?
Yes.
I am. I am. What is the y-intercept? What's that? -1. How do I know that? It's from the coordinate. Remember, the coordinate 0, comma, a number is the y-intercept. All y-intercepts have the coordinate 0, comma, y. 0, comma, a number. Okay? So then I can say the b value is -1. Now, am I given my slope here? No, but am I given a way to find it? Yes. I've got 2 points. Okay, so given 2 points, can you find the slope? That was also on our test. Right, given 2 points, find the slope. Remember, slope formula is y2 minus y1 over x2 minus x1. y2 minus y1 over x2 minus x1.
Why was it -1? I know you just confirmed it.
Because of this point right here.
I know, but isn't there? What about the other one?
What about this one?
Yeah.
That's not the y-intercept. Remember, the y-intercept is always the coordinate 0, comma, the number. That number is the b value. So it was here, -3. It was here, +2. So if I've given the coordinate 0, comma, -1, the b value is just -1. Now, for my slope, let's plug it in my formula. -1 minus 5 over 0 minus -3. Be careful with the minus the negative. A lot of people screwed that up on the test. Test grades went in on Saturday night, right? Fun Saturday night. Got test grades in. So a lot of people messed up that minus and negative. So please watch out for that. -1 minus 5 is a -6. 0 minus -3. Okay, watch out for that. That's +3. 0 minus -3. Don't believe me? Let's plug it in our calculator. 0 minus -3. +3. So -6 divided by 3 is a -2. All that work just to find the slope. But again, if you can get to this point, it's really easy to write our equation. Y is equal to -2x minus 1. All that finding the slope is just prep work to writing the equation. Let's do that again. Okay. I've got 0, -5.8 and 8, -5.8. Again, I should be able to identify my slope and my y-intercept. What is my y-intercept in this case? -5.8. 0, -5.8. So here, -5.8. Now, let's find my slope. y2, -5.8. Minus y1, -5.8. Oops. Divided by x minus x. Well, what is -5.8 minus -5.8? 0. Not -11.6 or whatever. It's 0. What is 0 divided by 8? 0. Glad somebody didn't say undefined. It's 0. Okay, we had this on our first slide. We had this in our first example. Slope of 0, I could write it as y is equal to 0x minus 8. But what should I do with that 0x? Gone. Y equals -8. Oh wait, I'm sorry, negative 5.8. Negative 5.8, I'm sorry. Forgot the 5 point. Questions about that? Let's do one more of those. Same type of thing. Not changing a thing here. We still need that. Some people did. I'm not changing a thing here. I'm staying with my identify the m and the b, figure out the slope, plug it into the equation. M and the b. What's my b value in this case? Negative 6. And I see that right here. Now let's find my slope. M, 9 minus negative 6 divided by 3 minus 0. 9 minus negative 6 divided by 3 minus 0. 15 over 3 is 5. Yeah, 9 minus negative 6 is a 15. Be careful with that. That would be like 9 plus 6. Double negative cancels to positive. So 9 plus 6 is 15. 15 divided by 3 is 5. Okay? All right, so my m is 5. And now I can write my equation. Y equals 5x minus 6. So again, just adding a new layer on the top of it. Now we can't just count the boxes to find the slope. We need to actually use the slope formula to find the slope. So let's add one more layer on the top. This is on the top of the back. Write a linear function f with the values f of 0 equals 10, f of 6 equals 34. Okay. If I wanted to write the equation, write the function, again, I need to figure out my m and my b. But they're giving it to us in function notation. They're giving us stuff in function notation. What does this f of 0 equals 10 actually mean?
0.
What's that?
Would it be 0? Or would it just be 10?
It would be the coordinate 0, comma 10. That's what we mean, right? 0, comma 10. So f of 6 equals 34 tells me what? 6, comma 34. Again, that's when I introduced function notation, I said that's why, you can go ahead and put it in the box. That's why function notation is so useful. Because it gives me the full coordinate, gives me both input and output, gives me both domain and range. Okay, so now this takes me back to the last slide. This is the exact same thing we did on the bottom of the last page. What's my b value, folks? 10. And I see that right here. And now I have 2 points. I can find m. M is 34 minus 10 over 6 minus 0. Y minus y over x minus x. Okay, 34 minus 10 is 24. 6 minus 0 is 6. So m is 4. Okay, so my equation is y equals 4x plus 10. Now, I'm only going to change one little thing to this. Does anybody know what I'm going to change? Yeah, read the first couple lines. Write a linear function f. Okay, so should I write it as y equals? No, let's write it as f of x equals 4x plus 10. That's the only thing I'm going to change. Honestly, that's really nitpicky. If you gave me y equals 4x plus 10, I'd probably be pretty happy. But this is one of those types of things that the state test will do. It'll say, give me a function. Call it f. And if you write y equals, they're going to take a point off. Even if you got the equation right. Because you didn't give a function, you gave an equation. You give relations. Let's do that one more time. Write a linear function f. Okay, same premise. Yes?
What exactly are we doing?
Well, you're kind of jumping in 3/4 of the way through the class, so I would hold off for a minute and then watch the video later tonight. Okay. Write a linear function f with the values f of 0 equals 9 and f of 8 equals 7. Okay, what is f of 0 equal 9? Tell me. 0, comma 9. What is f of 8 equals 7? Tell me. 8, comma 7. Okay, now I'm back to just given 2 points, write the equation. But they're nice to us because they gave us the b value. We're going to talk about later on in section 4.2, we're going to talk about, well, what happens when we're not given the b value? What happens when these are just 2 random points and one of them isn't the y-intercept? Well, so what is my b value here? 9. Let's figure out what my slope is. 7 minus 9 over 8 minus 0. Well, negative 2 over 8. 7 minus 9 is negative 2. 8 minus 0 is 8. Can I leave negative 2/8? No. It's got to reduce down.
Negative 1 over 4.
Very good. So negative 1/4. So I would say the equation is y is equal to negative 1/4 x plus 9. And then say, well, if they want it in function notation, which is what the problem is asking, let's give it back in function notation. F of x equals negative 1/4 x plus 9. Again, if you got to the point where you said y equals negative 1/4 x plus 9, I'd be happy. But we're just being particular here. Questions about that? Okay. Let's take our word problem here. Helen, she's in a bike race. She has already biked 10 miles and is now biking at a rate of 18 miles per hour. Her distance as a function of time is shown on the graph. Write an equation that represents the distance Helen has biked as a function of time. All right. What type of equation can I come up with? Y equals mx plus b. So what's my m and my b? What's my equation that I can come up with here? I'm traveling at a rate of 18 miles per hour and I've already biked 10 miles. Yep.
Wait, so like the equation?
Yeah.
It would be like, would it be slope and intercept again?
Yeah, slope intercept. Yep, that's just what I'm asking for. But what's my m and my b here in this problem?
10 and 18.
10 and 18. So what's what?
Y equals 10 miles.
The other way.
18 miles
18x plus.
plus 10 miles.
Good. How do I know which one goes where? Well, remember that the rate is the slope. And you're going to hear me identify that again. Now, it says write an equation as a function of time. Okay, it's asking for it in a function again. Honestly, I left that like that first period. We could write f of x equals 18x plus 10 as well, if we're being picky. Okay, part B says identify the slope and the y-intercept, and let's tell what they mean. Well, the slope of this, again, is 18. And 18 in the context, I mean, I'm just reading it from the problem, is miles per hour. What I'm going to make note of is that this is the rate. That's the rate. And I'm going to remind you guys that the slope is always the rate throughout this chapter. Every time we do a problem, word problem, slope is rate. The b value is 10, which is your y-intercept. What does my 10 actually mean in this case? Good. Miles already biked. 10 miles. Miles. Already biked. What am I going to say here? That's your starting amount. Your y-intercept is always going to be your initial amount, your starting amount, your first piece. And then lastly, part C. How far will Helen have biked after 2 hours? So I'm really finding f of 2, which is 18 times 2 plus 10. Let's plug it in our calculators here. 18 times 2 plus 10, which gets me 46. So f of 2 is 46, so 46 miles. Questions about that? I was hoping to give you about 10 minutes to work on your homework. Okay, give you 9. Got it already up here. Let me turn off the video. So long, everybody following along at home.